Hello and welcome to a new episode of Agile TD Mondays. Today with Mike Talks, who will share his favorite infrastructure recipes with you, but not before I have told you to register for the Agile Testing Days 2017 in Potsdam. Save up to 275 euros on your registration with our early bird discount prices. So go to agiletestingdays.com/register and book your tickets now. And now it's your turn, Mike.
Hi there, Kia ora from New Zealand. I'm here to talk to you today about fun times in environment provisioning testing. Well, that's what the titles say. A little bit about myself. I am a test manager at Datacom. I do a lot of writing about software testing. You might have come across my blog. I also have written an introduction to testing called How to Test, which is a free book. Go get it now if you've never heard of it. I'm also an occasional international speaker. And I will be doing a workshop at Agile Test Days in November on chatbots and how to build a chatbot, so please come along. So that's enough about me. As I said, I'm a test manager at Datacom, but who are Datacom? You've probably never heard of them. We are one of Asia Pacific's leading IT-based service providers. And that means, like a lot of people in IT, we provide software, but more than that, we also provide the infrastructure that it runs on for a lot of government organizations, particularly in New Zealand, but also a lot of businesses as well. And we provide that infrastructure in good old-fashioned servers. We're increasingly providing some cloud infrastructure, and we're looking at doing more and more with AWS as well. So infrastructure is quite an important part of what we do. Sometimes we provide the infrastructure, we don't even provide the software. So what is infrastructure testing, and what's the big deal? Well, infrastructure testing is confirming that the architectural components that are required for an environment are present, and that environment can be production. It can be a test environment, and that they're also behaving as we expect them. Now, infrastructure testing doesn't require an application to be present. But as you'll see a little bit later, it does help a lot if you do have access to one. So we're talking about testing an environment. What are the typical kind of attributes of an environment? Well, first of all, most of our environments, particularly production ones, tend to be what we call split site, which means that we have a whole farm of servers that are in one location and another farm of servers that are in another location. Within New Zealand, we typically talk about having servers in Wellington and servers in Auckland, our two biggest cities. And that gives them a bit of redundancy. So if something happens in Wellington, like unfortunately we had a large earthquake last year, or Auckland, for instance, has a power cut, it allows us to provide some kind of continuity of service, because we've got servers both in Wellington and Auckland that can operate completely independent. What kind of servers have we got? Well, first of all, we've got a web server, and this is basically what your internet browser will interact with, and it provides the web pages that you actually see when you connect to one of our services. Somewhere below that, the web layer will talk to an application layer, which holds where really most of what we program, all the fun stuff of what we program is. Most of our business rules, if somebody's over 18, they can have this, if not. That tends to be in our application layer. And then right back at the bottom, we tend to have a database which stores all our records and every transaction that we do, creates new users, audits, all the good stuff is kept in the database. Now, obviously, to make a kind of continuity of experience, whether you're in Wellington or Auckland, it helps that your same records are at both. So we also have a replication between the two databases in Wellington and Auckland, so that there's the same information in both databases. So that's pretty much standard fare at the minute. So what can we test in something like that? Well, first of all, quite importantly, I'll basically go through a a load of architectural diagrams and documents, and it helps us know that all the servers that are supposed to be there are there and they're live. It also helps to know that they've got the right specification. This is part of infrastructure testing. It's really a verification level. It's useful to be able to check that backups can be used to rebuild servers and database. It's useful to know that database information is replicated. You've got the same information on both your sites. It's also useful to know that servers are connected together as expected. So the web application layer talks to the web layer talks to the application layer, talks to the database. And finally, servers on each site should be able to function completely independently. There's no dependencies from Wellington to Auckland. Otherwise, it's a bit of a redundant exercise. So why bother with infrastructure testing? Don't you get infrastructure testing for free when you functionally test anyway? If you do what we traditionally call system testing or user acceptance testing, that uses an environment, and if you're doing that testing in an environment, surely it tests your infrastructure. Well, it's true to a point. If everything works, it's really great. But really, in such a complex environment, when you've got so many moving parts and things that you've never checked before, if something goes wrong, it's very difficult to say, okay, which actual cog in this complex machine isn't working. So what we try and do with unit testing, what we try and do with infrastructure testing, is we try and inspect a piece at a time as it's put together. It's one of the reasons why we don't wait to have an application to start testing. We start looking at the infrastructure as it's delivered. It's quite analogous to unit testing in software testing. We're looking at a piece at a time. Something has been added to our environment. How can we check that it's roughly working? Now, a lot of the things I'm going to talk about are quite technical things. So far, when we talked about an infrastructure, we've talked about providing environments. So you need to have experience with something like Unix or a Windows server. You need networking people to check the connectivity between them all. You need a database guru. Now, obviously, it's very rare for testers to have all those skills. I'm really great at SQL queries. They don't really let me loose inside the database that often. This is one of the reasons why pairing is necessary. You find the people that are actually building this who really have the skills, and you sit with them and you play a game of show me. I want to see something. But it's really replicates the pairing process. They're the ones that tend to be doing all the hands-on testing, and you're that voice behind them, coaching them, saying, I'd like to see an example of something happening, and we'll talk about some of those later. It also uses a little bit of scripting as well, because what you tend to do is you come up with a plan of all the things you want to do, and you have to kind of roughly script them out, just so you know, okay, I'm going to need to pair. I need to spend some time with somebody here. I need to spend some time with a database admin. I need to spend some time with a Unix person, and just plan out the time that you need to spend in these sessions with people. So what I'm going to do now is I'm just going to talk you through some of the typical infrastructure recipes that I know I and a lot of my fellow colleagues at Datacom use. Now, one of my first ports of call is monitoring testing. If you look at the server diagram that we looked at before, we've got web app and database services on different sites, but are they up or are they down? Within Datacom, we use a tool called Nagios, which we've customized quite heavily for most of our services. And it allows us to monitor on a dashboard like this a lot of statuses for different servers. The most fundamental of being, of course, is it responding? Is it live? And these traffic lights tell us a lot of information of things. But more than just telling us if a server is up or down, it allows us to actually look inside the infrastructure and find out things like how many cores has it got, how much load is on the computers. This is a bit like it's a little bit like what you get on control when you control Alt Delete, and you run the tool that I can't remember at the minute for Windows that allows you to see how much memory you're using as well, because how much memory you're using, how much your CPU is using, but it also gives us information for things like the naming of servers, which is useful, the IP addresses, the network traffic that's going through your servers, the memory that's installed, how much memory is free, how much swap space you've got, how much hard disk space you've got, both being used and free. So it gives you a good overall status of the system. It also can be linked to things like alerts, so that if you start to run low on hard disk space, you'll get a little ping. You'll get a ping of a text saying, that we're at a certain yellow alert or a red alert status according to where you set your thresholds. So it's really useful to have someone to go through the servers and make sure that all those things are right, that the server's built to spec, and all the alerts that you need are in place. Secondly, we've got backups. Now, a lot of people will, every server has a backup process. So there are files being stored every night. I worked on a project a few years ago, back in the UK, where we were storing this every night, and what we hadn't realised is the fact that although the backups were happening, they weren't usable. So it really helps to take your backups and actually try and rebuild a server just to prove that those backups are good. So this is the typical scenario that we'll do, where we'll mark down one of our servers, in this case the application server. We use the backups to generate a new application server. These are all typically at the moment virtual machines. So we'll shut down one of our servers, create a new virtual server, and then we'll move that server across, get it back up, and then we'll do some kind of smoke testing afterwards, just to prove that yes, we've replaced it and everything's working, and it just continues to work. Much later in the project, we'll start doing that against the clock to prove that we can meet a particular service level agreement and be able to turn something like that around in about 2 hours. Database replication. This was probably one of my more fun activities. I really enjoy doing this. For this, our database guys tend to be in a different city, and we have a Skype session, so I appear in their heads over the headset as we go through a session together. And what we're doing here is we're trying to confirm that the replication between the Wellington and Auckland databases is happening and it's working correctly. And at this point, we might not have anything smoke testable on the system, so we just spend time in the two databases themselves. And typically, what we'll do is we'll go into the Wellington database, and my database guru will create a record, for instance, me, in the Wellington database, and we'll check both databases before to make sure I'm not in either database. And then, by the magic of replication, we'll go over to Auckland and we'll look for that record, and sure enough, that record will be there. What will then happen is, typically, my database guy will turn off the replication, and we'll create a new record. This time we'll create a record for my son. And we'll check Wellington, and we'll confirm that Wellington doesn't have that record, but Auckland does. We'll turn the replication back on, and bing, my son record should appear within the Wellington database. And that gives us a lot of confidence that the replication process is going backwards and forwards. But because we're thorough and we like to leave things tidy afterwards, we'll then go through a process of deleting my record, confirming it's deleted in Auckland, deleting my son's record, confirming it's deleted in Wellington. It's a good fun test. Then we come on to connectivity. So we've talked about having, so far, if you probably noticed in these, I've not connected anything together. Well, we've got web servers, app servers, database servers. We want to really be able to prove that the web server is interacting with the app server, is interacting with the database. Well, how can we do that? Well, one way that we can do it is we can remote log into one of these servers and do telnet or webcat commands between the servers to confirm, yes, we can talk from one server to another. What we're trying to do is make sure there's no firewall settings or any restrictions between the two servers that's preventing comms going on between them. That's sometimes been a problem. Obviously, we've got an application, like I said. Smoke testing with the application is really good because, you know, if it works with the application, we've got some confidence that later testing will go through quite well. But we don't always have access to an application, and sometimes it makes sense. What we do is we'll develop a test harness on the web, app, and database that will replicate the comms between the servers as closely as possible, using ideally the same socket connections, because we want to make sure that these, if we follow the specs that we've got in our architectural documents, that we'll be able to communicate between these servers. So for telnet commands, what we'll do is we'll remote log into the application, and we'll confirm that we can go from the application layer in Wellington to the web layer, web server in Wellington, or the database server in Wellington. But then we might want to check that, for instance, there might be restrictions that mean that we can't cross connect from the Wellington site to the Auckland site. So we might try and connect from the app server in Wellington to the Auckland web server, or the Auckland app server, or the Auckland database server, and all those things should be prevented. We could try a smoke test using our application. And for this, it's just something that creates a record, retrieves a record, updates a record, or deletes a record. We don't want to do lots and lots of the business testing. That's for a later thing. But what we want to do is just use the front end to create some kind of record in our database. And those kind of tests are called CRUD tests. Typically, we're using them to put something in the database and confirm that we can see it in the web layer because it's on the page. If we can do that, then it gives us confidence that, yeah, web app database and backup again is all working fine. Now, smoke testing is usually the better of these options because it's a good confidence check for later testing. It's cheaper than building a test harness, and it tests deployment for the application, which is useful. But one of the problems can be that the application really might not be ready right now. It might be still a few months away before it's ready to do something like that. And finally, that it has the potential for people that are testing it to be distracted by non-infrastructure issues. Everyone's concerned that testers will start picking spelling mistakes in a very early prototype of your application, when really at this stage we just really want it to do an end-to-end, put something in the database, retrieve it. That's all we should be interested in. Finally, we'll take a quick look at site autonomy. So typically, we've got a Wellington server, we get it working, we create a copy to create our Auckland server. Now, if that copy has been too literal, there will be a lot of dependencies in the Auckland server that are still pointing to Wellington services. And that's going to affect the ability for Auckland to work completely independently of Wellington. So the question we're trying to ask is, what if Wellington has hidden dependencies on Auckland? Or what if Auckland has hidden dependencies on Wellington? For a test like this, simply we'll do a smoke test, and we'll run with Wellington up and everything on Auckland down. And if we can do that end-to-end, putting something in the database and back, we know that there are no hidden dependencies. So it's not that Wellington is secretly using the Auckland web database. And then we'll do a repeat where we'll run with Wellington down and Auckland up. If those are both working, we know that each site can function with the other site down, which is a big help. So in summary, Check your environment as it's being delivered. Problems found early means that you'll have so much less pain later on. You can pair with others to increase your technical competency. Don't be afraid to ask, how can we test this? Work really closely with your technical people. Go through your architectural documents and say, how are these things testable? And finally, don't leave it for the application team to find obvious problems.
Bart Merck will tell you how you can make unit testing a team effort. Tune in Monday at 4 p.m. and watch his talk live.
I saw Bart at the previous Agile testing Wellington, Agile testing in Potsdam. He was absolutely amazing, and that I'm sure is going to be an absolutely fantastic webinar. And I won't get up at 2 o'clock to watch it, but I promise I will try and catch it sometime after.
Good morning.
Guten Tag.
Thank you very much.
Great. Thank you for having me.
Yeah.
I'm about to go back to bed. It's 3 a.m. over here.
Yes. Thank you very much for getting up for Agile TD Mondays. And thank you for your talk. It was a pleasure.
Thank you very much.
And I see you.
See you in Potsdam.
Yes.
Cheers. Thank you.
Bye.
Bye.